Right, welcome to today's stream, and you will see that we've got a lesson on geometrical reasoning today. So without further ado, what we will do is we'll get stuck into the first question. I'm going to give you 4 minutes to have a go at it, just to warm you up. Right, that might have been a little long, but that's how long you'd get in an exam if you were doing that question in a GCSE paper. So what we've got to do is we've got to realise this tangent to a circle, therefore it's right angles to the line OP. And we can find out the gradient of OP because the y coordinate here is 3 and the x coordinate here is 4. So the gradient of OP equals 3 over 4. Therefore, gradient the tangent is equal to minus 4 over 3. And if you hopefully remember, the equation of a straight line is given by y minus y1 equals mx minus x1. y1 and x1, or x1, y1, is the coordinates of a point on the line. We've got that p, and m is the gradient minus 4/3. So we've got y minus 3 equals minus 4/3 x minus 4. And that would be good enough for an equation of tangent, but let's just tidy this up. Times that by 3, we get 3y minus 9 minus 4 times x minus 4 times minus 4 is plus 15. So we're going to get 3y plus 4x equals 25 if we turn those all into integer values. Okay, right. Next question. Let's give you another 4 minutes to have a go at this one. Okay, now this one required a little less working than the last one, but it required possibly a little bit more thinking to get to the answer. So let's start off. What is the point? Now, what you needed to recognize was that you had a right angle here, and that you got this length here is 16. So therefore, we can find out the radius by using a little bit of trigonometry. So OA will equal 16 sine 30, and sine of 30 is a half, so therefore OA equals A. And we know that you should know that the form of a circle is x squared plus y squared is equal to r squared, and we've got x and y, so we've got 3p squared plus p squared must equal 8 squared. That gives us 9p squared plus p squared equals 4, so 10p squared equals 4p squared equals 6.4, and you put that into a calculator and you get an answer of p is equal to 2.5298, so on. But it says to one decimal place, so p is equal to 2.5 to one decimal place. No units given, so no unit in my answer. Right, they're going to start getting a little bit more challenging, especially if you're not a big fan of circle theorems. So, 4 minutes for the next one as well. Okay, so here we go. It might be worth drawing in these lines to help. Now, what you should realise is you have a tangent here, so there's a bit of a theme going on, a bit of a tangent theme for today, right angles between tangent and radius. And you should realise that OPA is equal to 90 due to tangent and radius. Theorems. So we've got OPA equals 90, which also actually equals, we've got OSA, and we've got that equal to CRO, and we've got that equal to CQO. So all those are equal to 90. So this means, therefore, if that's equal to 90 and that's equal to 90, then this angle here is equal to 180 minus 2x. So therefore, POS equals 180 minus 2x. Okay, we could do angles and quadrilateral. You could say is your reason, because you can, or you could just write out the full working. You could have written the full working as equal to 360 minus 90 minus 90 minus 2x. Okay, to get this, and then we'd have got that on. So equals 180 minus 2x. Similarly, we're going to get this angle here. QOR is equal to 180 minus y. Now, my mistake is when I was doing this earlier for the first time, as I misread the question. I thought it said find an expression of x in terms of y, and I kept finding out 360 equals 360. Surprise, surprise. Anyway, that's not what we need to do. We need to find the angle of POQ in terms of x and y. So we know that these two are equal, and we know these are equal because that is 90, 90. It's a similar sort of thing. So therefore, we know that these are going to be equal as well. So therefore, POQ will equal a half of, if that's going to be equal to 180 minus y, 360 minus 180 minus 2x minus 180 minus y. Let's put it behind my head. We get 12 bits. Final brackets in. So the 360 cancels. So we're just left with a half of going to be 2x. That's not 2y there. Apologies. Plus y there. Minus 5. So we get plus y there. So we get x plus y over 2 for our final answer. Right. Another one of those types of questions coming up. Hopefully you managed to get one out. If you didn't, you can Okay, so the trick is to know what line to draw in and to start off with maybe just calling this one X here. So we want to prove that CAB is equal to ABC. ABC. So we're going to prove that this is equal to this. And the trick is to draw this line in here and create a cyclic quadrilateral here. So we then know that this is going to be 180 minus X. And this is the best way to go about doing these problems, is to just, and especially when you're trying to prove that this angle equals this angle, call one of them X and start off a known. It's a little bit hard if you start off. I started off the first time I had to go at this. I started off down here with X and proved to be a bit more demanding than when I actually went up here and called this X. So if what you're doing doesn't lead to an easy answer, then try rubbing out and starting again, and which is what I did. And so therefore this must be X. And because we've got the center, this is a radius, and this is a radius, this must be X. So if we are writing that out, so we let, what's that, CAB equal to X. So we've got the ideas for our proof. We now just got to write out our proof properly. This implies that CRO is equal to 180 minus X, as CAOR is a side. I'm just going to write quad there for shortness. Therefore, ORB is equal to X, angles of a straight line. Line add up to 180. Therefore, what we got C, they call it ABC. ABC will also equal X, as OR equals OB, as they're both radii. There you go. And there's your proof explained with all the theorems you've used along the way. Right, last question. Good luck. Congruence question. Seeing it is not the problem, it's explaining it that might be the trickier part. So here we go. 4 minutes to try and pull out this problem. Okay, so we're going to show that ABC, so where have we got it? ABC is congruent to DCB. Now it's made a lot easier for the fact that AED is an equilateral triangle. So that's 60, that's 60, and that is 60. Makes life a little bit easier. We can start off that BC is common to both. So we can start off with that. Okay. So that gives us one side. Remember, we are looking for ASA or SAS or AAS. So angle, side, angle, side, or angle, angle, side, to show that it's congruent. Now we know that DE here is equal to AE, because we've got an equilateral triangle, right? And then we're going to know that this angle here, BEC, must equal 60, okay, because vertically opposite angles. Then we can show that CBD is equal to DAC. So CBD equals DAC, which equals 60 degrees. That's angles in the same segment. Same for if we're doing from BCE, BCA. BCA equals ADB. So therefore, EBC is an equilateral triangle. And this might not be the quickest way of doing it, but it's quite an easy way of doing it. So if that's an equilateral triangle, then this side equals this side, and then we've got that side equals that side. So therefore, we've got D E equals AE, and we've got CE equals EB, and from that we get AC must equal DB. So we have got, therefore we've got SAS, we've got outside angle side, and therefore we have shown we've shown two sides, this side, this side, and this side, this side, and we've shown the angles in between are equal. Therefore, we have. Right, that's our last question for today. Do remember, change this, go there, in that. You'll be able to see the tabs on the top. We're just doing geometry. If you go into the extension tab, we've got a new set of questions for today, and I've got the answers from last week, kindly donated. The extension questions are all kindly donated by a man called Mr. Saeed, so thanks to him. Do feel free to send me or him your answers to have a look at when you've done your extension questions. That's it for today. See you again next week.